Hello everyone, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. It is reverse linked list 2. Given the head of the singly linked list and two integers left and right, we have to reverse the nodes from the list from the position left to right position and return the reversed list. So this is the problem statement. So you are given this linked list and the left and right are the given. Left is 2 and right is 4. So we have to reverse this part of the linked list alone 4 3 2 and we have to say 1 4 3 2 5. So this is our problem. Hope it makes self-explanatory. So we can analyze first. What we have to do is first we can think of naive approach. First it is given to 1 2 3 4, then we have to reverse this whole linked list, then we can do it as 4 3 2 1. So similar way, if we are given a range left to right, we can go and stand to this position, yeah, this first position of this left, and then we can just reverse the linked list till this right position. After reversing that linked list, then what we can do is you can see that this previous linked list tail pointer, since it is one, it is okay, but if we consider there are two nodes here, this tail pointer of this linked list is pointing to the head of this reversed linked list. Consider this is the linked list, and if we reverse it, this 4 becomes the head. So this tail pointer of this linked list will be pointing to the head of this linked list. Similar way, the currently the curve pointer, when we start the reversing the linked list, the curve pointer will be pointing to 2. So this will be the head of this current linked list for the range of left to right, which is 2 to 4. So this head will be pointing to the this 5, which is nothing but the head of this linked list. If we consider this is another part of linked list, this will be pointing to this linked list, here head of this linked list. So that way, if we take care of those two conditions, then we can solve this problem. First we can quickly write the reverse linked list code, then it will be more clear what we have to do. So first we will be having a previous is null, then then next will be null, next will be null, and the curve will be pointing to head. First, a naive way, we will be writing the reverse linked list function itself. First, we will reverse the linked list. Reverse the linked list. What we have to do is we have to just reverse the linked list within that left to right range. So we can have a while loop which starts from left, and we can just run till my right. And we can also check another condition, my curve is present or not. If my curve is null, we don't want to proceed further. So we will be just reversing the linked list here. Now we can just write the reverse linked list code itself as that. What is that code? First, my next will be pointing to my curve of next. Then my curve of next will be pointing to my previous. Then my previous will be pointing to my curve, and my curve will point to my next. So this will be my reverse linked list code, right? So this will be my reverse linked list curve, but whenever we come inside this loop, we have to do a left plus plus for next node. If since we are making sure that we are reversing the linked list that are in the range of left to right. So now what we can do is, before reversing this linked list, we have to make this curve point to this 2. Initially the curve is pointing to 1, so we have to make this curve pointing to this 2. So what we can do is we can traverse for int I equals to 1. If we are having a left is 2, then we are traversing only one node. If my left is 3, we will be traversing two nodes. So we can start from I equals to 1, I less than left, I plus plus. We can just move the curve equal to curve of next. But we also want to have a track of this node, a tail of this linked list node, right? So we can have a previous node. If we are coming and traverse pointing to curve when this left when we reach this left equal to 2, then this previous node will be my tail of that linked list. So we can have a node list node star previous I will say of tail of tail node. I can say it as tail node, which is pointing to null initially. So whenever I come into this loop, I will say my tail node is nothing but my cur, and then I will move my cur equal to cur of next. So now we will be having a track of this tail node, and we also want to have a track of this head node, right? This cur node will be my head node. This cur node after this iteration, this cur is my head of this linked list 2 3 4. So this head, this cur node should be pointing to the head of this linked list node, this part, right? 5, if it is there, if it is there 5 6 7, then it should point to this head of this node. Whenever we complete this iteration, my cur will be pointing to this node, right? After this reversing the linked list, my current node will be pointing to this head of this linked list. So what we can do is we can check for one condition. So before that, we also want to have the keep track of this head node. So what we can do here is this cur node after this iteration, my cur node is the head. We can say it as, instead we can say it as tail of the reversed linked list. After reversing this linked list, this will be the tail, 2 will be the tail. So we can say it as like that. Sorry, tail of reversed linked list, which is my cur. So whenever I come out of this after reversing this linked list, I will be checking whether this condition, for this condition, what will be that condition? If my tail of linked list if my cur is present, if my cur is present, then I will say it as I think I don't want to check whether this is cur is present or not at all. Directly I can say that tail of reversed linked list of next will be my cur. So it will be pointing to this head of this part of this linked list. So I will be saying the tail of reversed linked list of next is nothing but my cur. I can say it. So we have, after reversing this linked list, we have pointed this 2 of next to this 5, but we have to point this head 1 of next to be my head of the reversed linked list. So what we can do is we can say like this: if my tail node is present, then what I can say is tail node of my next will be my previous will be the head of this reversed linked list. So tail node of next will be my previous. Else tail node is not present, that is tail node is next, so nothing but head is my previous, right? We can say like this. So hope we have attached all the links. Now we can just run our code. We are not returning anything, we will just return our head. So it got accepted. We will use the example test cases as well. It got accepted. We will let us submit our code. So here the time complexity will be order of n. We are traversing only once, and it got accepted. Hope you like this video. And if I want to improve in anything, let me know in the comments. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.